Hello and welcome to Math 253 Calculus 3 here at Cañada College. My name is Lapuz, and in this video we will be looking at checkpoint 5.37. They want us to calculate the centroid of the region between the curves y is equal to x and y is equal to square root of x with a uniform density within the interval for x between 0 and 1. All right, centroid. So the centroid is essentially the center of mass, except it's given for a lamina that has uniform density. The idea is that if it has uniform density, your mass will be some integral of some constant k. So that's the density. So let's pretend our density is equal to k. And then your moments are going to be y times k and x times k, because k is your density function, which is constant. Now, those are constants that can be moved outside of the integral. So when you find the center of mass, x bar and y bar, you can essentially think of those k's being outside of the x bar, being outside of the moments mx and my, and also being outside of the mass m, and they would cancel each other out. So the centroid is essentially given by the same formulas, except instead of calling it x bar and y bar, you can really just call it x sub c and y sub c, because of the fact that it does have constant density. All right. So we're going to be moving to do the same thing, where we're going to be integrating and finding some values. So we actually, in our process, when we're trying to find a centroid, we actually can ignore k, because they would end up canceling in the centroid anyways. So let's do that. Let's do the part where we're going to ignore k, and then we're going to find these values. So let's find the mass first. And so let's draw this out. And I think, like I said, the limits are probably given here already. And so I would say the x, well, if we draw these curves, y equals x and y equals the square root of x, we see this, it's hard to see, but if we zoom in, we see this little area going between 0 and 1 here. So this little space is probably what we want. And so if we do set up the set of inequalities where we say 0 less than or equal to y less than or equal to, I'm sorry, not 0, but our lower limit here looks like it'll be x. That's the graph in the bottom in that little region. So x less than or equal to y less than or equal to the square root of x. We see this. And just to confirm, we should integrate this between, for x limits between 0 and 1. Okay, now if we go anything that's less than 1, we're not going to cover the whole thing, right? So that's why we want these constant limits to be able to cover the area that we want. So this is going to be our set of inequalities, kind of given here. Let's just take a quick snapshot of that. And also, it's always good to have these drawings in your work that you're keeping, and I hope you're keeping all your work as you do these problems. All right, so now let's set up the integral to find our mass. Our mass will equal to the double integral over the region. We're not calling it anything. Let's call it d for this one. And again, it's just 1 times dA. So in that particular case, this will end up being a double integral. So an integral, the inner integral, or the outer integral, sorry, is going to be the constant limits from 0 to 1. And then we'll have the inner integral with functions x and the square root of x. All right. And our dA will become dy first because that's the function part. This is a type 1 region, and then dx later. Okay, we should be able to do this by hand, but let's just, for the sake of doing it quickly, let's do it using calculator. So we have x and the square root of x. Square root, nope. Oh, there it goes. Square root of x. And that's our x, and our y. Our y goes from x to the square root of x, and our y goes from 0 to 1. And probably would have been able to do it by now. So here is our mass. It's going to be 1/6. Okay. Now that we have our mass equal to 1/6, let's figure out our mx and my. So let's just get everything set up. M sub x is going to be equal to this thing with a y in it. And again, there should be a k here, but the k's will cancel in our centroid problem. So I'm just going to choose to ignore that. So this is our y function. And then we need to figure out what this is. It's probably not going to be 1/6. And then our y will be the same thing, except we'll have an x in it. So let's throw an x in here. And again, probably not going to be 1/6, but we'll check it out. All right, so let's go to our Wolfram alpha and have this figure out what happens when we put y in here. And in this case, we get 1/12. Let's take a picture of that. And then what happens when we put x in here? We will get 1/15. Okay. So now we have values, and then to figure out our centroid, we just put those on top of each other. Just remember that the one with the x is my, so it's the centroid for the x coordinate is going to be my divided by little m. So let's get this set up. Centroid is going to be given by, well, the first one is y or x sub c, and that's going to be a fraction. The fraction is going to be m sub y over m. And what are those values that we got? M sub y, this one was the one that's 1/15. And the m was 1/6. All right, I think we can cancel that. Let's see. That would be 2/5, I believe, if we cancel the 3's out. All right, so we have x sub c. Oops. And then let's get the y sub c. Let's copy and paste. And then I have mx this time. And mx this time is 1/12. So let's get that down here. Let's just change this. And then let's see. I think this will end up being 1/2. All right, just to check, 2/5 and 1/2, 2/5 and 1/2. So that's it. So that should be our solution. Okay, I hope that helps. Good luck.